Welcome to Yurix AI. This is Lecture 2 of LLMs from Scratch, Zero to Builder. In our previous explainer, we laid out a pretty grand vision, right? We're not just here to look at flashy apps. We're going on a journey to understand how these models truly work from the ground up. So today, we're laying the absolute groundwork you need before we even think about writing a single line of code. Let's dive right in.
Today, we've got 6 clear learning objectives on the agenda. First, we'll define what large language models actually are. Second, we'll explore the power of the word large. Third, we'll compare LLMs versus early text models. Fourth, we'll uncover the secret sauce that makes them so powerful. Fifth, we'll untangle some of those confusing AI buzzwords. And finally, we'll look at some real-world applications.
All right, starting off with Section 1. What exactly are LLMs?
So unless you've been completely off the grid for the last couple of years, you've definitely heard this term, and you've probably used tools like ChatGPT. But at its core, a large language model is simply a neural network designed to understand, generate, and respond to human-like text. There are really 2 key parts of this definition, and we're going to start with that first one, the neural network. Now, if you're a beginner, please don't let the phrase neural network intimidate you. It sounds complex. But a neural network is really just a computing system that's roughly inspired by the circuitry inside our own brains. It's made up of these stacked layers of digital neurons. You feed input data into one end, it passes through all these connected layers, and it spits out an output. And we've actually used these networks for years for things like detecting tumors in medical images, or, powering self-driving cars.
But here's the kicker for LLMs. We take that exact neural network architecture and apply it specifically to text. And that brings us to the second half of our definition, understanding, generating, and responding to text just like a human would. Think about ChatGPT for a second. If you prompt it to help you plan a relaxing day, it doesn't just hand you a robotic, generic list. It asks about your hobbies. If you say you like reading, it responds perfectly, maybe suggesting a morning meditation, a healthy breakfast, and then a dedicated 2-hour reading block. It behaves and converses dynamically.
Moving right along to Section 2, the significance of scale, or really the power of large.
You might be wondering, why do we specifically call them large language models? Why not just language models? Well, to understand that, we need to quickly define a super crucial term, and that is parameters. Parameters are basically the internal variables or weights that a model learns during its training phase. I want you to think of them as tiny internal dials that the network tweaks and adjusts to get better at its job. The total number of these parameters is the standard way we measure the size and capability of an AI model.
And the explosive evolution of these models is frankly staggering. Just look at this. GPT-1 had roughly 100 million parameters, and hey, that was a huge deal at the time. But then, GPT-2 jumped to 1.5 billion parameters, and GPT-3, an absolutely astonishing 175 billion parameters. Today, we're dealing with modern models scaling well into the trillions.
Just to put that into a little historical context for you, back in the 1950s and 60s, early models barely had 100 to 1,000 parameters. For decades, the growth was pretty slow. It wasn't until the 2020s that we hit this vertical logarithmic explosion, jumping to billions and now over 1 trillion parameters. So this unprecedented, massive scale, that is exactly why the word large is absolutely mandatory here.
Okay, Section 3, LLMs versus earlier NLP. Let's compare these text models.
Long before LLMs took over the world, we still had text-based computer programs. So how is what we have today actually any different? Before we compare them, let's quickly define NLP, natural language processing. NLP is just the broader field of AI that focuses on how computers interact with human language. Both those older models and our modern LLMs fall right under this big NLP umbrella.
So what's the actual difference? Well, it all comes down to flexibility. Earlier NLP models were incredibly rigid and narrow. You literally had to build one highly specific model just to translate French, and then a completely different separate model just to analyze if a movie review was positive or negative. Modern LLMs, on the other hand, are remarkably generic. You can use the exact same model to translate a document, write Python code, or draft an email to a friend about booking movie tickets, complete with custom emojis, entirely from scratch.
Which brings us to Section 4, Transformers, the secret sauce. How did we unlock this incredible flexibility? Well, when I say transformers, I'm definitely not talking about the movie robots that turn into cars. In our context, the transformer architecture is a groundbreaking neural network design introduced by Google Brain researchers back in 2017.
It completely revolutionized how machines process language because it allowed them to look at the entire context of a sentence all at once, rather than just reading it word by word, step by step.
The research paper that introduced this was called Attention is All You Need. And to give you a sense of just how massive this breakthrough was, that single 15-page paper garnered over 100,000 citations in just 5 years. It entirely reshaped the landscape of artificial intelligence overnight. We are actually going to dedicate several future lectures just to understanding the math and the mechanics inside this specific paper.
Now, if you take away just one thing from today's explainer, make it this. It is the combination of the transformer architecture plus that massive parameter scale we talked about earlier that allowed LLMs to leap so far past older NLP methods. That combination right there, that is the magic bullet.
All right, Section 5, Untangling AI Terminology. Let's clear up some of these buzzwords.
You hear these terms thrown around on the news interchangeably all the time, right? AI, ML, deep learning, what do they all actually mean? The absolute easiest way to untangle this is by picturing a set of Russian nesting dolls, where each concept fits neatly inside a larger one. The biggest, outermost doll is artificial intelligence, or AI. This covers literally any machine showing human-like intelligence, even a simple, rule-based airline chatbot that just follows a strict script. Open that up, and inside you have machine learning, or ML. This is where machines actually learn from data, like a decision tree predicting heart disease. Inside ML is deep learning, which specifically uses those multi-layered neural networks we discussed earlier. Think of image recognition software. And finally, the smallest, innermost doll at the very core? That is large language models, a highly specific subset of deep learning that deals exclusively with text.
Okay, you might be thinking, but what about generative AI? Well, generative AI actually spans across these categories. It's essentially the mixture of LLMs and deep learning used to create entirely new content. While LLMs deal strictly with generating text, generative AI is a much broader term because it includes generating other modalities too, like creating brand new images, audio, and even video completely from scratch.
Finally, Section 6, Real-World Applications. What can we actually build with this? The applications are honestly endlessly expanding, but they generally fall into 5 main pillars. First up, content creation. You could ask an LLM to instantly write a poem about the solar system in the style of a 1920s detective novel. Second, chatbots, which are completely revolutionizing customer service for major banks and airlines. Third, machine translation, instantly and accurately translating that detective poem into fluent French. Fourth, text generation. Imagine a teacher generating an entire, detailed school lesson plan on the physics of gravity in about 5 seconds. And fifth, sentiment analysis, scanning thousands of social media posts in real time to detect things like hate speech. Seeing all these incredible applications is super inspiring, right? The sky really is the limit here. But it brings us to a critical, provocative question to close out today's lecture. Moving forward, will you just be someone who downloads code from the internet and blindly runs it? Or will you be someone who truly understands the nuts and bolts? Because true impact and true innovation comes from making your foundation clear and understanding exactly how that transformer architecture works under the hood. And that is exactly what we're going to do. In our next explainer, we'll cover the specific stages of building an LLM from the ground up, preparing us to finally dive into the code. Once you understand the secrets under the hood, what groundbreaking tool will you create? So like, share, subscribe to Yurix AI for a new lecture every day, hit the bell,